Welcome to aminacademy.com. In modular arithmetics, let us discuss about prime numbers. Prime numbers are the natural numbers greater than 1 with exactly two factors, 1 and the number itself. Any number having the factors 1 and the number itself is called a prime number. For example, take 3. 3 can be expressed as 3 into 1 only, no other possibility, so 3 is a prime number. 5 is also 5 and 1. Suppose 18 is 1 into 3, 2 into 3, like we can express. Means not only this, other ways also expressed. So 18 is not a prime number, since it have a factors more than 1 and it's the number itself. So further this 18 can be expressed in other ways also, so it is not a prime. This 3 is a prime, 5 is a prime. The only even prime is 2, other primes are odd numbers. A prime number is a positive integer having exactly two factors, that is 1 and the number itself, just we expressed here. If p is a prime, then its only factors are necessarily 1 and p itself. Any numbers that does not allow this is termed a composite number, which can be factored into other positive integers. The other than a prime numbers is called a composite numbers. Another way of defining it is a positive number or integer which is not a product of any other two positive integers other than 1 and the number itself is a prime number. The prime number was discovered by Eratosthenes of Greece. He took the example of a sieve of filter out of the prime numbers from a list of natural numbers and drain out the composite numbers. That means you have to write number of numbers in order and remove the non-primes. First remove the even numbers except 2, and other you have to check one by one that those are prime numbers listed. That means up to 1 to 1000 we listed here the prime numbers. Suppose 2, 3, 5, 7, 11, like this it goes. It is better to remember because it's useful for further studies of prime numbers. Now list out some things here. Smallest prime number is 2 and largest prime number ever is used. As of November 2022, the largest known prime number they found is 2 power 825899933 minus 1. This is a general this highest prime number ever now discovered here. This is how many digits? Look at here. 2,48,006 here 24862048 digits. This much number of digits, you cannot imagine that. This much number of digits is ever known largest prime numbers. It was founded by the great internet Mersenne Prime search, that is in 2018 Mersenne Primes, and that they found this is the largest prime numbers ever. 2 is only the even prime number and the rest of the prime numbers are odd numbers, hence called odd prime numbers. Twin prime numbers. The prime numbers with only one composite numbers between them are called twin prime numbers or twin primes. The other definition of twin primes number is the pair of prime numbers that are differed by 2 only. For example, 3 and 5 is a prime numbers. These are twin primes because the difference between those numbers 5 and 3 is 2. The other examples of the twin primes are here. 5 and 7 is a twin primes, so the difference between 7 and 5 is 2. like 11, 13, 17, 19, 29, 31. These are twin primes. The 73 minus 71 is 2. So these are twin primes. Co-prime numbers. Two prime numbers are called co-prime to each other if their highest common factor is 1 only. Prime numbers and co-prime numbers are not the same. For example, 6 and 13 are co-prime because that the common factor is 1, but that each are not prime numbers. Here 6 is not prime, but 13 is prime, but these together called co-prime because the common factors between 6 and 13 is only 1, other is not. Now a prime number has two factors only, that is 1 and itself, 1 and that number itself. Composite numbers, yes, composite number has more than two factors. Opposite to prime number is a composite number. It can be that the prime numbers can be divided by 1 and the number itself. For example, 2 is divisible by 1 and 2, but composite number, it can be divided by all its factors. For example, 6 is a composite number, is divisible by 1, 2, 3 and 6 itself. For example of prime number is 2, 3, 7, 11, like here composite numbers are 4, 8, 10, 15, like, because that more than two factors is here. Each number have more than two factors. How to find a prime number? The following two methods will help you to find whether the given prime is a prime or not. Given number is a prime or not. First one, we know that 2 is the only even prime number, and only the two consecutive natural numbers which are prime are 2 and 3 only. Apart from those, here every prime numbers can be written in the form of 6n plus 1 or 6n minus 1, except the multiples of prime numbers, like that is 2, 5, 7, 9. Like here, for example, take the number 11. That 11 can be expressed 6 into 2 minus 1, where 2 is a prime number. Therefore, we are expressing 6n minus 1. Suppose consider the 13. 13 can be expressed 6 into 2 plus 1. Here 6 into 2 plus 1 is 12 plus 1 is 13. Therefore, this also expressed that 13 is expressed as 6n plus 1. Therefore, some prime numbers can be expressed as 6n plus 1 into 6n minus 1, where here some other numbers here. Suppose 25 is not a prime number, but here 6 into 4 plus 1. Suppose 25 is 6 into 4 plus 1, it can be expressed, but this 4 is not a prime, therefore 25 is not a prime number. Same like that, this expression is 6n plus 1 or 6n minus 1, where n must be a prime number. Method 2, we know that prime numbers greater than 40 and below formula can be used. This is n squared plus n plus 41. So some prime numbers can be expressed x6, suppose n squared plus n plus 41 is a prime number. Give n is suppose some prime, suppose n is 2 squared plus 2 plus 41. 2 squared is 4, 4 plus 2 is 6 plus 41 is 47 is a prime number. So we can express any prime numbers in terms of n squared plus n plus 41, where n is a prime number. Suppose n equal to 5, that is 5 squared plus 5 into 41, so which is equal 5 squared is 25 plus 5 is 30, 30 plus 41 is 71 is a prime. Further, general expression for the prime number is 2n minus 1, where n is a prime. This also some expression for the prime numbers. Look at here, 2 power, any prime number is suppose 5, 2 power 5 minus 1. 2 power 5 is 32 minus 1 is 31 is a prime number. Suppose 2 power 8 minus 1. 2 power 8 is, 2 power 6 is 64, 2 power 7 is 128, 256. So this is 256. 2 power, this 8 is not a prime, we should express this 8 also a prime number. Suppose 2 power 7. 2 power 7 is, 2 power 5 is 32, 2 power 6 is 64, 128. So it is 128 minus 1 is 127 is a prime number. Like that, we can express some ways about the prime numbers. Also, the prime numbers have some interesting facts also. Now, first we will discuss about geometric meaning of prime numbers. Suppose, let's start with the example. So, given 12 pieces of square 4 tiles, we can assemble them into a rectangular shape in more than one way. Suppose 12 can be expressed, look, 12 can be expressed, 12 into 1, 6 into 2, 4 into 3. We do not distinguish between 2 and 6, 6 and 2, both are same. Therefore, these are the expression for the 12 as a factors. But this is not a prime number because 12 can be expressed in different ways, not only by number itself and 1, and it can be expressed different ways, so it's not a prime number. That means first we have to use the factors of the given number and check whether it is a prime or not. Next, here like suppose the 2, 3 and 5 are the special prime numbers, hold a special place of factorization because all these are prime numbers. Suppose you want to factorize any number, first you have to check with the factors 2, 3, 5 first, then it continues. Now next one, divisibility of any number divisible by 3. So divisibility by 3. So take some number 58. 58 adding them is 5 plus 8 is 13. Further adding is 1 plus 3 is 4. So it's not divisible by 3. Any number 125. Here 1252. We check whether it is divisible by 3 or not. Here 1 plus 2 plus 5 plus 2. 1 plus 2 is 3. 3 plus 5 is 8. 8 plus 2 is 10. 10 plus 1 plus 0 is 1. So it is not 3, not divisible by 3. Suppose take 81, 813, which we can check 8 plus 1 plus 3. 8 plus 1 is 9, 9 plus 3 is 12. Further expressed 1 plus 2 equal 3, it is divisible. Therefore 813 is divisible by 3. Like this we can check. And divisible by 5. by 5 is last digit must be 0 or last digit is 0 or 5. Suppose 815 is divisible by 5. 950 is divisible by 5 because it's finished end with 0. Like this we can check the divisibility of some other numbers in future videos. Now we discussed so far about some prime numbers, some details. If you have that, please subscribe our YouTube channel.